Hello everyone. So this is a contest discussion video of Leetcode Biweekly. With me, I have Ishan Kulkarni, who is knight at Leetcode and 4-star at CodeChef. So we are going to discuss the approaches of all the four questions of Leetcode Biweekly contest 145. Okay, so let's start with the first question. Hello Ishan, am I audible to you? You can open your mic, bro.
Yes, yes, you are
Yes,
audible.
yeah. So first question was minimum operations to make the array values equal to k. So it has tagged easy, but I don't think so. Like it was that easy. Okay, so
हाँ हाँ ठीक है.
you are given an array, okay, nums and an integer k. So basically, what the question is saying that an integer h is valid if all the values of in the array that are strictly greater than h are identical. Okay, so for example, this 10 8 10 8, a valid integer is h is equal to 9 because nums of I is greater than 9. Okay, so uh, in this question they are describing an integer h, and the integer h is that integer uh, which above which all the integers should be equal. In array you have to find that integer. So in this array, if you take h is equal to 9, so all the elements which are greater than 9, which is 10, only 10, 10 and 10 are equal. Okay, so that is an integer h. Okay, so this is the definition of h. So what you have to do in this question, so select an integer h that is valid for the current values in nums. So you have to select that type of integer h, and what you have to do, you have to replace all that h, like all that array, all that elements which are greater than h with h. Okay, so what will happen in this question is, let's suppose you sort this first. Okay, so the array will be 2 4 and triple 5. Okay, so now let's say you take 4 as an h. Okay, so the elements which are greater than 4 are 5 5 and 5. Okay, so what you will do, you will now replace that 5 with 4. So now what you will get, 2 and 4 times 4. Okay, now again what you will do, you will select an integer 2. Okay, and what you will do, the elements which are greater than 2. So there are four elements whose values are 4. So all are equal, and you will replace all those value, all those four value with 2. So now all the elements in the array will become equal to 2. Okay, and that is equal to k. So you have to find out that can you make the all the elements of the array equal to k in by performing this h wala operation. If you can, then return the number of minimum operations. If you can't, just return -1. So the approach of this question is very easy. The question is trying to confuse us, but it's very easy. Like you have to just sort the array. Okay, and initialize an answer variable. Okay, now from the back, like from back you have to track, like iterate. Okay, so what you have to do, you have to just find out how much times or like there are how much unique elements in the array. This code is doing the same thing. So in this there are how much unique elements, 2 4 and 5. So three unique elements. Okay, three unique elements. So 3 minus 1, like there will be only two operations possible in that. And also there will be one condition, if nums of 0 is less than k. So let's suppose here there was 1. Okay, so at last what would happen, you have to make all the elements 1. Okay, so this you would have got Ishan here till now that at
Yes,
last,
yes,
like which is the minimum number, all the elements would be equal to that number only. So if the
yes,
number is 1 in this, then all the elements would be get equal to 1 only if we apply these operations. So if 1, but 1 is less than 2, 1 is less than k. So if this will happen, we can't get our all the elements equal to k. So we have to return -1 in this case. So there, that's why I have written -1 here. And if
yes,
nums of 0 is equal to k, then I will return answer -1. So in this case, this is the case, like nums of 0, like sorted thing, sorted 0. So it is 2, and that is equal to k. So you will return answer -1, and else you will return answer. Yeah, so this
yes.
was the approach of first question. Okay, now let's move to second question. Yeah, this was the second question. So Ishan, can you like just try to explain it?
Yes. So If we read the question properly, then the question basically tells us that there is an array given, and
Okay.
which is called as the means the name of the array is strength, and the
Okay.
strength of I indicates the energy or the amount required to break that lock.
Hmm.
And we also have an integer x, which is a initial, we can say, which is initial factor, and at each minute it increases by 1. We also have an integer k, which is given in the question, and it tells us
Yes.
to it tells after destroying a lock we can increase x by that much factor. Means, for
Yes.
example,
Yes.
if we destroy a lock and k is 2, so next time x will become 3, that is 1 plus 2 3. So
Yes. Yes.
the final our output we have to print is the minimum time to break all the logs. If we see the constants here, then n is 8 actually. So we can clearly see that we can use brute force approach. And what will be the brute force will be, we can create
Recursion.
all permutations.
Yeah,
Yeah, with the
actually,
help
let's
of recursion.
see and test case, Ishan. So in the question, you are given an array and like the array length is n. So we have to break all the locks, okay? And to
Yes,
break the ith lock, you want at least strength of I energy. And at the initial,
yes,
you have zero energy. So let's see
yes,
here. And what is the crux of this question is that every minute your energy increases by k, not k, increases by x. Okay,
yes, yes.
and that x also increases if you break a lock x,
Log.
if you break a lock, then your x increases by k. So in this question,
Yes,
energy is increasing every minute and x is increasing every time you break a lock. Okay, so let's take an
yes,
example
yes,
here. So like in the first like zero, energy zero at time zero. So what you have done, you have break, you can't break anything again, Ishan, you can't break anything.
yes, yes,
Yeah,
yes,
so what you will do, like we will move to time one. At time one, energy will become one, that is like because x is 1 na, so 0 plus 1 1.
yes,
Now you can break third lock because your energy is 1 and you want only one to break. So
yes,
now you will break third lock, and now x will x was 1 but x will increase by 1 because k is 1.
yes.
So every time you break the lock, the x increases. Now at
Increases, yes,
time, yeah, at time 2 what will happen, uh, x will increase by 2. So and yeah,
yes,
if you break a lock now, your x becomes 0 every time you break a lock, not x, energy becomes 0. It
yes,
is written, yes, here. It is written here, after breaking the lock, the energy of the sword reset to 0. So here the energy becomes 0, became 0, and then it increased by 2.
2,
So
yes,
now energy is 2. So you can't break anything now here because 3 and 4 are greater than 2. And after that, your energy will become 4 because it increased
yes,
by 2.
yes,
And then yeah, you can break the second lock, this fourth, and you break it. Now your x increased to 3 to 3.
yes,
Like it was 2 and it increased by 3, increased by 1, and it got to 3.
yeah.
And next time the energy is now 3 and you break the first lock. Okay, so
Yes.
Ishan, like we can do a recursion now.
Yeah, and, by seeing the constants, we can just apply
Yeah.
recursion here.
Hmm.
Like we can take first element, then go towards other indexes, or we can, if we don't take first element and go
Hmm.
towards other indexes. So yes, we can
Yes.
apply recursion here.
Yeah, so basically what we'll do, like we will take three, and like at the first we will try to take three, then we will also
Yes,
try to take four, also we'll try to take one. Okay,
yes,
now the minimum, like which will be the minimum answer that we will return.
yes,
So like to understand it more clearly, what we can say is like, yeah, let's suppose first we are breaking the lock 3. Okay, how much
yes,
time we require to break it. So we require it 3 divided by x. Like if you
yes,
calculate it mathematically, you will get, you will require 3 divided by x, or 3 divided by
yeah,
x plus 1 at
yeah,
most. So first you will do, you will try to break 3. Now if you try broke 3, now you have two options. You first break 4 or 1.
yes,
So
yes,
first you will try to break 4 and then calculate answer. Also you will try to break 1, then calculate answer. So
Yes.
the order can be anything like break 341, 143,
Yes.
413, anything, and you have
Yes.
to
That
calculate
is,
for
we are
all.
basically seeing all the permutations.
Yeah, so we have to see all the permutations, and it can be seen by recursion also, or there can be any other method also.
Mm.
So okay. Yeah, so I made a recursion call, simple recursion call here. So I will explain the recursion. So what I'm doing is the strength array is given. What I will do, the base case is if the size of the array like is zero, like all the locks have been broken, then I will return zero time because zero time is required. Now I will initialize answer with max value. Okay, here the size I have initialized. Now I will traverse in the strength array that like first I will try to break 3, then 4, then 1, and then do the operations. So this is the like maths that will tell you that if you want to break 3, then how much time you will require. So you will require z time. Okay, now you will remove the element which you have broke. So if I broke 3, I will remove that from array, and then what I will do, I will call for next. Now if I have broke 3, now I will just make my array list is now 4 and 1 only, and I will call the function again, and it will return the minimum number of time which is required to break only 4 and 1. Okay, now so and z is the time required to break 3. So yeah, z plus that will be the answer, and I likewise I will do this for every combination, and the minimum will be the answer. Yes, and I will
Yes.
return it finally. Okay.
And the time complexity will be
Yeah,
n factorial.
n factorial. Yeah, and n is here 8 factorial. Actually, let's submit it and try. Okay, so now it's getting accepted, I guess. Yeah, it's getting accepted. Okay, so now let's move on to the third question. Third question is, yeah, this is the question: digit operations to make two integers equal. So Ishan, you are better in graph,
Yes.
you can try it.
Yes. So yeah, first of all, let's understand the question. What the question says that you are given two integers and an m, and the most important is they have the same length, that is same
Yeah.
number of digits, and
Yes.
we there are some operations given, and in each operation we can pick any digit and increase it by one, or we can pick at any digit or decrease it by one.
The
But
condition is
we have to.
that, yeah, like while increasing we can't pick a digit 9, because if we increase
Yes.
it, we pick 9 and then it will increase to 10, but we don't want that. And we
Yes.
while decreasing it, the digit should not be 0, because it will be
Yes.
-1. Yes.
Minus one, yes. So, and what again? What the condition is? Important condition is that while let's say we have a number n and we changed any digit. For example, let's take example 16, and or let's take example 10. First test case. Let's say we increase the second number digit, that is, let's change 0 to 1, it becomes 11, but we cannot do this transformation because 11 is a prime number, so this transformation is not allowed. And at each transformation the cost is basically the sum of the digits. For example, I'm from a number n, I'm going to n1. So it's like n plus n1. The cost is n plus n1. Let's take the first test case. We are going from 20 to 21. So the cost is actually 41. Similarly, after that I'm going to 22. So it's like 63. 41 plus 22 63, and from 22 to I'm going to 12, that is 63 plus 12 is 75, and
Okay.
the initial number also we have to consider, that is 75 plus 10, which is 85. So
Okay.
by seeing this question, uh, uh, Priyanshu and I first thought as this as a DP question, but
It's a
I
graph
don't think
question.
this, it is a graph question. I don't think it is a DP. I
So
think
I guess
due to some.
we should make it clear that you have to, like, you are given n and you have to make n equal to m. Okay, and in
Yes,
like to do that you have to do these operations, like you can increase any digit or decrease any digit. So
yes,
yeah, your target is to uh, make n equal to m and with very less cost. And the cost,
yes,
that cost is the number of nodes which are coming in the So
Yes.
basically this is the extra. Now you have to shortest path, you have to calculate
Yes.
shortest
Yes.
path.
Yeah, we can, for example, n is like a source node and m is like a destination node. And by we know the source and destination, so we can simply apply Dijkstra. Why Dijkstra? Because we have to first of all, like, we have to find the minimum path. No? So the big question here is that what will be the edge weight or how the edges are formed. So for example, let's take n equal to 10,
Hmm.
and let's say what I just perform a operation like in the digit 1 in 10. Let's increase the 1 by 2, it becomes
Hmm.
20. So it's like there was a node 10, and after performing operation I go to node 20. So
Yeah.
for example, there is a edge between 10 and 20 whose
Hmm.
edge weight will be 20 plus 10. That is the
Yeah,
cost
30.
to reach 20, that will be 30.
Yes.
So I hope that you are able to visualize the graph
Yes,
here.
yes. Now, if now you want to reach 21 from 10, then the cost will be 10 plus 20 plus 21.
Yes, yeah,
Yes.
that will be the cost. So I hope you everyone know the Dijkstra algorithm.
If you
And
don't know, you can just search YouTube and watch any of
yes,
those
yes,
big YouTubers video.
yeah. So first, let's show the code then.
Yes. Let me copy it. Control. Okay, yeah. So the code is very like lengthy, but yeah, the logic is very simple. So I am initializing a class here because we obviously we need priority queue in this to solve the extra. And so the pair is what, so your every node will have
If
two things.
you are in C++ audience, then you can just use the pair data structure here.
Basically every node will contain two things. The string, we will first convert this, the code is getting lengthy because of this thing only, that you have to convert integer to string and string to integer, and therefore Ishan and I was like stuck for almost yeah, long
And
hour,
the most
long time.
important and missed thing I think you should tell him about the question,
Yeah,
the
yeah,
leading zeros.
yeah. Actually, this question is actually not properly, what we can
Design
say,
question.
not not properly designed. Like they have missed one thing to say, that the thing is that see 0236. Now there is no need to write 0236. We can just write 236 now. Uh, so
Yeah, I mean,
so
basically the question wanted to say that we cannot go to a node or number which has leading zeros.
yes, we
But they
can't do.
have not explicitly mentioned in that question. And I and Priyanshu were means we cracked the logic in very few time, but due to that incomplete explanation, we were not able to
Hmm, yes.
identify. And then we saw the discussion forum, and we got
Hmm.
to know this.
Okay, so every node will contain two things: the cost to reaching that node, till reaching that node from source, and the string x, like what is the number in the string form. And this is the logic to get those pair in ascending order from priority queue. Yeah, so this is the prime number logic to check like whether a number is prime or not.
Yes.
Yeah, now this is the main thing. So like base case is simple. If n or m, like any one is prime number, so there can be not any path, because
Yes.
it is mentioned in question that the path that can't contain the prime number, so we'll return
Yes.
minus 1. Next, what we have, Ishan, this thing, this
Yes.
why we
So
have
after
used
that,
this. Hmm.
first of all, we use priority queue in Dijkstra algorithm, and we also have a, if you know that in standard Dijkstra algorithm, we also have a distance array. But here, as we are considering strings, because uh, for we have to change each digit in number, so we are converting here string, and here string cannot be, means we cannot store string in an array, so we have created a hash map for distance purposes. You
Yes.
can see line number 37, and here we have declared a priority queue. We use a priority queue data structure. So anyone who don't know priority queue, it's like at top the minimum distance node is stored first, and after that this is, while from the starting of 41th line is like a standard Dijkstra algorithm. We are choosing the top node, and the top node will be always one with the minimum distance.
Yeah, before
And
that we are pushing the initializing step, like we are pushing the source
yeah,
node
yeah, source node, yes.
and their distance, and also we are putting in the distance array or map, we are putting that
Yes.
to n. Yeah, now you can continue.
Yes, yes, and we are extracting the top node of the priority queue. There are some functions you can look here, like dot remove and cost according to
Yes.
the class
Yeah, yeah.
implemented. After that, this if condition for a 45th line is like if we have got a destination node, then we can just return the cost here. If you don't want to write this line here, you can write it outside of the while loop.
But it's
It
fine. Yeah.
doesn't matter. Ah, yes.
Now,
And after that, we have iterated in the current number, which I have converted
mm,
into the string, and these all are looking big, but
yeah.
these are just the conditions
Uh,
that are given in
yeah,
the
yeah.
question.
So in this, there is we are doing nothing. We are just trying to do all the possibles. Like if we take an example 10, so what are the possibles? We like first what we'll do, we'll go character by character. We can increase 1 to 2. So 20 is an
Yes,
option. Now, yeah, we can decrease 1 to 0 also, but we will not do that. Why we will not do?
yes,
Because of that condition that the numbers cannot contain leading 0. So that's
yes,
why here is that condition. Okay. And yeah, and this is the condition that the number should not be 0, because if we decrease the number which is
yes.
0, then it will get negative.
And it will
Yes.
cause leading
uh,
zeros, and this is not mentioned, and I mean this is
mm,
expected by the question actually.
uh, so
Yes,
yeah,
and after that,
here,
we have also checked the prime number condition, and yes, you can continue, Priyansh.
yeah, so if the number is not prime, then only we will update, like this is the relaxation step. I
Yes.
will write it, relaxation of Dijkstra. So now,
Okay, relaxation is means we have got a better distance to a particular node, and if we have got a better distance to a particular node, then we can just push it in priority queue, because if we have got a better distance to a node, means if I took take that distance, then my further journey or further nodes in the graph will have a minimizing distance. So
yes.
this is nothing but relaxation step in Dijkstra algorithm.
Yes, so now we, this is where this we have done for increasing, not actually increasing, decreasing. Here we can see
Yes.
we have decreased it. Okay, and now the same thing we will do for increasing. Okay,
Yes.
so we have increased it, and now then yes, at last, if we don't meet this condition, we don't get m anywhere, we will return -1, as we will uh, which will signify that we can't reach from n to m, because there are prime numbers in it every path. Okay, yeah, so
Yes.
this will be the solution. Let's try to submit it. Yes, it's getting accepted 100%. Complexity, can't we can't see. Okay, yeah, that's the lead codes limit. Now let's move on to next question, which is actually a good question.
Okay.
uh, yes.
Okay.
Wait, let's actually wait here, bhai.
इंग्लिश क्यों बोल रहा हूँ
Yes,
मैं
yes, yes. Let's move on to the fourth question. Okay, so
fourth
it's
question
an
and
hard
fourth
question.
fourth
Finally,
question is marked as hard, and the question is called as count connected components in LCM graph. So first let's read the question here. You are given an array of integer nums and also a positive integer threshold. Okay, there is also a graph consisting of n nodes, with the ith node having a value of nums of I, and two nodes I and j in the graph are connected via an undirected edge if LCM of both the numbers is less than equal to threshold. So this means that we are given n nodes, and there will be an edge between any two nodes if the above condition is met, and the condition is that both numbers LCM should be less than equal to threshold. And we have
let's take
to
an
after
example and actually see like
yes.
which nodes can connect. So in the
Yeah,
graph,
let's take the numbers 2, 4, 3, 8. For example, 2, 4, the else, and let's say the threshold is like 5. So the LCM of 2 and 4 is like 4. Yes, LCM is nothing but least common multiple. That is the least number which is divisible by, which is a multiple of both the numbers. Like
yes,
if we say the LCM of number 2 and 4 is 4, because 4 is a multiple of 2, and 4 is also a multiple of 4 itself. So I hope the definition of LCM is understood. And let's take a first example here, 24839, and the threshold is 5. So if we see in the explanation, this photo, then there is an edge between 2 and 4, because 2 and 4 LCM is 4, and it is less than threshold.
Less than
Similarly,
5, yeah.
2 and, yeah, less than 5, yeah. So, and the LCM of 2 and 8 is 8, which is not less than equal to threshold. Therefore, there is not an edge. And the LCM of 4 and 8 is 4. Yeah, is 8 actually, and this is also not less than equal to threshold. So, therefore, there is only edge between two nodes, that is 2 and 4, and this is the
Yes.
final graph. And if we
Yeah,
see
so
the
we have
number
to
of
just
connected
make the graph, and the graph will made by like the condition, this condition, this is the very important
Yes,
condition.
after making the graph, we have to count the connected components. Connected components is nothing but like disconnected parts. For example, you can see here means, okay. So the first basic understanding,
So how much,
or the
connected components will be there in this graph? Like this is one
yeah,
connected
that will
component,
be,
one,
yes,
two,
and
three, and four.
2, 3,
Four
and
is the
4.
answer. Yes, then
4 is the
four is
answer
the
for
answer.
this question.
For this,
If
I
we
guess
take the
two is the
second,
answer. Hmm.
yes.
Yes, because
So
these is the this is the one connected component, and this 12 is another.
second
Yes.
connected. So, if we talk about the brute force or the most naive solution, that I think it should click everyone's mind, is that let's loop for each number. For example, let's take example one, 24839. For example two, I will loop for all other numbers and check if both LCM is less than equal to 5 or not. And
Yes.
for calculating LCM, there is a formula like A into B, means I can check 2 in if I'm checking 2 and 4, the LCM of 2 and 4 is nothing but 2 into 4 upon GCD of 2 comma 4. It's a
Yes.
formula basic, and we will
Yes.
get the LCM. But this will be, if you see, this will be a n square approach, and this will be not be
Yeah, so
accepted
what
because
Ishan is saying is like you just take that nums array. Okay, now you take like first take 2 and like loop it to every number 4, 8, 3, 9, and check if the LCM of that is less than 5. Just connect 2 with that number, and now do the
yes,
same thing for 4, same thing for 8. So this will be n square. Like we will take
yes.
the time n square in making the graph only, but you can see the constraints. N
Yeah,
square will
it's
not work.
1e5, so this will not be accepted.
Hmm.
So we have to think about a less,
Hmm.
more optimized solution.
Hmm.
So this will not be accepted. So what we can do is, the first most important observation is that if you see, or if we generalize it, that LCM of A comma B is actually, it should be greater than equal to maximum of A comma B. What I mean is, LCM of 2 comma 4 is 4, that it is greater than maximum of 2 comma 4, that is 4. So
Yes.
means any two numbers LCA should be greater than equal to the maximum among them.
Yes.
So the else and here the LCM range is like till threshold. So there is no sense of keeping the numbers which are greater than threshold, because
Yes.
if we take LCM with that, then we will get the numbers which are bigger than a threshold. For example, here, let's take 8. If we take any number with 8, the LCM will be sure shot bigger than 8. For example,
Yes.
if I take LCM of 3 and 8, it's like 24, because
Hmm.
8 into 3 is 24 and 3 into 8 is 24. It is bigger than threshold. So first of all, the most important observation is there is no sense of keeping the numbers which are bigger than threshold. This is the first observation, and I have implemented this year in uh, this 40, yes, 40th line. Here I have taken
Yes.
a set, and I have inserted the numbers which are basically less than equal
Less
to
than.
threshold, because
So what? Yeah,
yeah.
yeah. So like to sum up, like the problem now gets divided into only like not divided, not get shortened into one thing, that you have to now make the graph for only those elements which are less than 5,
Yes.
because the elements which are greater than 5, less than equal to 5, greater than 5, those elements can't be, like will be single only, they can't be get connected with anyone because their LCM will greater than 5 only.
Yes.
So
So
yeah,
they
and
are basically a single nodes, will I initialized int answer equal to n minus the set size. That means that the this answer is basically those nodes which will be like isolated. They will not be in the component, any component, because they are bigger than threshold, and any number taken with them, the resultant LCM will be greater than threshold. So this was the most first and crucial step in the solution. After that, I have used here this DSU. I think this can be solved without DSU also, but I have
But
taken a
why
DSU.
DSU? Why DSU is used? Like
Yes,
can
yes.
you?
The DSU is used here because this is like a dynamic graph. And whenever we speak of dynamic graph, what I mean by dynamic graph is that we are connecting the graph. I mean, I'm checking and I'm connecting the edges. I'm dynamically constructing the graph. And while doing this, DSU is a very effective data structure which almost big of one complexity, like constant
Okay,
complexity, it
okay.
gives us the connected
We are
component.
using DSU to basically create the graph and then
Yes,
check the connected components in it.
components in a more efficient way,
Uh,
or we can first create the graph and like do DFS after that. I think
yeah.
you have also
That
done the
I
same way.
have done that only. Yeah. So, but now
Wow.
that first thing is clear that we have to only consider those elements which are less than five, and we have to make a
Right.
graph of that. But how will we do that? Because that will be also n square if we try for first.
Yes, yes. Then here comes the important thing that we have first perform this crucial step of eliminating the numbers, but it still will be n square approach only. So what we can do is here that it's hard to explain, but you can imagine that. For example, if I take the number two, so I will list all the multiples of two which are under threshold. Why under threshold? Because it makes no sense taking beyond threshold, because it will not be the possible LCM candidate, right? So if I take the number 2, then the multiples will be 2, 4 till 4 here, because the threshold is 5, right? We
Five, yeah.
cannot take 6.
So what
Yes.
we'll do,
So
we will, yeah,
yeah.
if two is there, we will connect all the elements, all the multiples of two with two. Why we are doing it,
Yes.
you will get it afterwards. You will just connect like two with all with multiples which are less than five. So you are connecting two with four. Okay. Now you will do the same thing for four also. You will connect all the multiples of four which is less than five, and you will do the for eight. Actually, you will not do for eight because eight is greater than five, and you will do for three also.
Yes. So after this, what happens is, what exactly, why exactly it helps is, uh, I came through this conclusion because when I properly observed 2 and 3 in second example, basically, if you see the second test case, there is the 2 and 3 are connected. I was basically thinking how we can come to a conclusion that 2 and 3 becomes connected, and I came to a conclusion that 2 and 3's LCM is 6. So it's like what I can do is I can list all multiples of 2, I can list all multiples of 3, and if there is any multiple which is matching in both the cases, then it means that yes, they both are. I mean, they both can be connected. That means they both LCM is less than equal to threshold. So if you properly observe here in 50th line, uh, I have this for auto. This is actually for each loop. For each loop helps us to iterate in a set and map data structures actually. So if you properly see here,
Yeah. What are you saying?
yeah, yes, in 50th line, actually in 50th line of code, if you properly see that, what I have done here is I have taken the possible is my bo double s is nothing but my set in which I have inserted the elements which are less than equal to threshold from the first crucial step I have told that, and after that I have listed its multiples. And this DSU, I hope you all know DSU data structure. Of If you don't know, then you can follow any
Google it.
resources, like, yeah, you can follow it any YouTube channel. So DSU dot union by size, this function basically joins, or you can say that this creates an edge between this IT and J. So basically what IT and J is, if I take 2, in second example, if I take 2, then I am listing all its multiples, like
Less
2,
than 10.
4. Yes, which is less than 8, because I don't think there is any question why less than 10, because uh, if we take greater than 10, it doesn't make sense, because
LCM we
greater
can't.
than
We are
10
not
means,
allowed.
yeah, LCM does not allow that. It means the given condition. So 2, 4, 6, 8. So if it, then you the question might arise is 6 is not present in the array. Then why we will connect the edge between 2 and 6? It will help us when we are listing the multiples of 3 here. If I take the multiples of 3 which are less than equal to 10, that will be 3, 6, and 9. Okay. Now, if you see it, the 2's multiple have 6 and 3's multiple also have 6, like shown by Priyanshu in 39th line, that 2's multiple is also 6 and 3's multiple also is 6. And this is less than equal to threshold. So we can conclude that 2 and 3's LCM is present and it is less than equal to 10. So this was the main motive of
Yeah, and
listing
that
all the
means 2 and
multiples.
3 is connected.
Yes, 2 and 3 is connected, and
And
if you properly imagine the graph, that 2 is first initially connected with 6 and 3 afterwards connects with the 6. And
yeah,
if
so
you
they
have
are
studied,
forming the same connected component, so that
yes,
they will
yes,
not affect in the answer.
yes, because we have to count the connected components. So we have to not want to know the component size, right?
Yes, so
If
like
if if
yeah,
you
this is
if
the
they have
main.
mentioned like component size, then this might
Hmm.
create a problem.
Yeah, yeah. So this is the main thing. Like if 2 is connected to 6 and 3 is connected to 6, then 2 is also connected to 3, and
Yeah.
we can do this very like efficiently. Like or connect
Yes,
all
you
the
can
multiples
create
of
a
2.
adjacency matrix.
Yeah, connect all the multiples of 2 with 2, and also connect all the multiples of 3 with 3, and then the common multiples will merge 2 and 3 also, and they will be in same connect component. So
Yes.
this is the code for it. This is the part in which we are rejecting the elements which are greater than 10, and we are including that in answer. So in this we are having 12. Yeah, only 12 as greater than 10. So 12 is one connected components, and we can see here, and these all three numbers we have to work on, and we have to create a graph and then find how many connected components are there in this graph. So
Yes.
for that we have used disjoint union here. Okay.
Yes.
Yeah, so here this is a step where you are connecting all the elements, like with multiple. You are connecting 2 with its multiple, 3 with its multiple. Am I right, Ishan?
Yes, yes. And
Yes.
if you have studied DSU, then you have might have known this concept of ultimate parent. Means, for example, initially when I'm iterating in multiples, six becomes, and there is a edge between two and six. Similarly, when I iterate in the multiples of three and six, I connect three with six. But if you have seen previously that two is also connected with six, so in disjointed union, these two and three's ultimate parent becomes six, and this can be, and with the help of this ultimate parent concept in 50 from 57th line, I have counted the number of distinct parents actually.
Yes.
uh, yes, DSU dot find u parent is this function basically helps us to find the ultimate parent. Means you can say like that the leader of that component, and I have used set because I want distinct leaders, and the number of distinct leaders means the number of distinct components. And in this way you can calculate, or you can also use DFS approach also. Yeah.
Yeah, yeah. So basically, this code is creating the graph and also counting that st dot size is giving the number of connected components
Connected
we
components.
have in this graph, like the number which are
Yes.
less than threshold. So, and the answer is the numbers which are greater than threshold.
Greater
So,
than threshold.
adding them will give us the total number of connected components in the graph. Yes, it
Yes.
was actually good question. The concept was main concept was this, like uh, you have to connect all the multiples of a number with it, and also like the common multiples will the LCM means that only that common multiples.
Yes.
So yeah,
Yes.
in this thing there will be many multiples also connected, like for 2 and 3
Yes.
case, 2 will be connected to 12 also, and 3 will be
Yes.
also connected to 12, but 12 is not the LCM. LCM is 6,
Yes.
but it doesn't matter if you are including 12 also, because it will be in the same connected component. Yes,
Yes.
so
Yes.
it will not affect the number of connected
Yes. It
components.
will not affect the number of connected components, but it will affect the component size.
Yes, component size, yeah, but it will not get a stale because 10 raised to 5
Yes.
it
Yes.
is.
Yeah, because the multiples loop will actually run approximately for log n,
Yeah,
and the DSU functions are almost armatized complexity, and you can consider them as constant complexity.
Okay, so complexity of this would be, I guess, n log. Yeah, it's n log n actually. I have seen it before. Okay, so it was a nice question, and like solving all the four questions, up solving it was very great. And if, especially if you solve together, so it's very nice to solve. It's
Yes.
also very nice to explain. So how you are feeling, Ishan, after explaining all the four questions?
Yeah, it was great, especially the last two questions were based on graph concepts, and it were pretty interesting. And if you know the Dijkstra algorithm and DSU, then these last two questions were not that difficult. But obviously difficult, but not that difficult.
Yes, like intuition is like you have to think,
Yes, yes.
like it, maybe
If you
you are
have
not, will not,
previously,
maybe you will
yes,
be
if you
not
have
able to solve it
previously,
in contest, but you can
yes.
upsolve it. Yes, you can continue, Ishan. You were saying something.
Yes, yes. If you have previously solved these questions based on these concepts, then these questions are pretty easy. And I mean, if you solve means this, for example, this third question, it was a lot similar. Means such questions are present in Leetcode problem sets also. If you can see, like there are some BFS questions, there are some this Dijkstra algorithm questions. So this after seeing this third, I got immediately clicked that this is like a shortest path question, and this was Dijkstra because not why not BFS, because this the unit the weight edge weights were not unit weights, there was some non-unit weights, so we cannot use here BFS. So
Yes,
instead we
like
have
you
to
want
use
minimum.
Dijkstra.
Yes.
Yes.
Okay, so everyone, if you like this video, please like it and also subscribe it. Okay, so let's end
Yes.
this, Ishan, here.
Yes.
Okay,
Yes. Thank you.
yeah, okay, thank you all for watching.